So this video is following up on our lesson about adding with negative integers by moving to the idea of subtracting with negative integers. And much like the video with adding, we're going to start by talking about what the definition of subtraction is, the ways that we think about it, relate it back to addition and how it all works, and then finally get to some practice problems, and then a piece of advice for working with any sort of addition and subtraction with negative numbers that we can use for the rest of the chapter as well as the rest of the year. And if you ever have any confusions about how to add or subtract with negative numbers. So first, we're going to look at fundamentally what subtraction represents. And so if we're looking at the question of 25 minus 14, what does that really mean, and how can we think about it? So go ahead, pause the video, write down a few ideas. There are a few that I have in mind that we'll go through afterwards, but we'll talk more about that in class tomorrow. But go ahead, pause the video, jot a few ideas down for about 30 seconds, and then come back when you're ready to move on. So there are a few different ways that we can talk about subtraction. The first is to talk about subtraction as the taking away of objects from a larger group. Now this works when we're talking about positive number subtraction. Taking 14 objects away from a group of 25 makes sense. Taking 25 objects away from a group of 14 doesn't quite make sense, so we're going to have to find a new way of thinking about it before we can really dive into negative numbers. The second way that we can think about subtraction is by thinking about it as distance on a number line. And subtraction, we call it difference. When we talk about the answer to a subtraction problem. And when we look at a number line, one way we can think about it is what is the difference between their positions? That is, how far is, for example, 25 away from 14? When we do the subtraction in the familiar form, we get that 25 minus 14 is 11, and it just so happens that 25 and 14 are 11 units away from each other on a number line. Now that's kind of helpful when it comes to subtracting with positive numbers, but as soon as negative numbers get involved, it's not always entirely clear whether the answer should be positive or negative when we're talking about distance, and distance itself is always positive because it's just a space between. So this is getting more towards the idea of what we want to talk about. But we can look at it in one more way that's really going to be the way we think about it, and that's as the inverse operation of addition. And now we're familiar with the idea that addition and subtraction are inverses, meaning that if we start by adding 8 and then we subtract 8, we do those two operations right in a row, the two cancel each other out, and we're left with a difference of 0. We're back to where we started. So let's take a look at that number line and look at subtraction. As the inverse operation of addition, we talked about how addition really represented movement on a number line. So if we're going to add 12, that means we're going to move to the right by 12. And if we're going to subtract 20, that means we're going to move to the left by 20. And that's how we talked about addition. Movement on a number line. It helped us come up with some rules for what we do when we combine positive numbers, combine negative numbers, combine positive and negative numbers together. And now let's take a look at what that means when it comes to subtraction. Now, we know that if we're starting at 25, for example, and we wanted to take away, let's make it 15 to have it be easier here, we're going to get 10. So to go from 25 to 15 and or 25 to 10, we actually move to the left by 15. Well, that movement to the left by 15 that subtracting 15 represents also is the same thing that happens when we add a negative 15. No, I was about to write a negative 25. That's not what we want. That's what we get when we add a negative 15. Both of these are to the left by 15 units. So taking 15 away, especially if we're starting with a negative number, is the same as adding negative 15. Now, when it comes to talking about, for example, subtracting a negative 14 in the idea of movement on a number line, we know that negative 14, or adding a negative 14, is a movement to the left. Well, if adding a negative 14 is a movement to the left, and subtraction is the inverse, then subtracting this negative 14 should be movement to the right, because moving to the right can be thought of as the inverse, or the opposite, of moving to the left. Adding negative 14 moves to the left, subtracting negative 14 moves to the right, and moving to the right by 14 units is the exact same as adding 14. So what we discovered in the last two slides and those last two examples is that subtracting a positive number is the same as adding its opposite, which is negative 15. And subtracting a negative number is the same as adding its opposite, which is positive 14. Addition and subtraction being inverse operations, and there only being two directions on the number line, subtracting a number is the same as adding its opposite value. And that's how we subtract integers, or decimals, or fractions, or any type of number that we have. When it's negative, we add the opposite. So if it's 25 minus 37, we think about it as 25 plus negative 37. And then we end up at negative 12 using those same rules for addition that we had before. On the flip side of the coin, rather, if we're taking away negative 37, subtracting negative 37, that's the opposite of moving left, because negative 37 moves left. The opposite of moving left is moving right, and that's the same as adding 37, which gives us 62. Don't worry if you're still a little bit confused. We'll go through a few example problems to see what that means. But go ahead, pause the video, and you're going to write down a few things here. You're going to write down this sentence: to subtract integers, you add the opposite. You're going to write down these two examples, so you can have some examples in your notebook before we move on. And then once you've written those down, we'll go to some example problems and give you some practice. Go ahead, pause the video, and move on and unpause when you're ready to move on. So let's go back to that problem that we saw before, 25 minus negative 14. We always said that the opposite of 14 to the left is 14 to the right. So that's the same as 25 plus 14. 25 plus 14 is the same as 39. Now we're going to draw that on a number line. Here's 25. It's called an open number line. We want to do the opposite of moving to the left by 14, so we moved to the right by 14, and we get to 39. In the proper Steelers colors that we have right there. So I'm going to go ahead and do the top two, or rather the left two problems and examples. You're going to do the right two, and then I have one more slide of practice problems for you. On the left, we have negative 22 minus 15. Here's negative 22. Here's subtracting 15, which is moving to the left. It's the same as negative 22 plus negative 15. We're moving away from 0, so we add their absolute values and get negative 37. On the bottom, we have negative 40 minus negative 55 on a number line. Here's negative 40. The opposite of moving 55 to the left is 55 to the right. So it's the same as negative 40 plus 55. That takes us past 0 by 15 units. And gives us a sum of 15, or because 55 and 40 have opposite signs, 55 minus 40 is 15, and 15 is our sum because 55 is greater. Go ahead, work on the two problems on the right using the idea that subtracting a number is the same as adding its opposite. Come back when you're ready to move on, and we have one more slide after this. Well, the first one we don't have to do a whole lot with. 27 minus 17 is 10. We're familiar with that. But if we wanted to envision it on the number line, here's 27, there's taking 17 away, and we end up at 10. For 42 minus negative 17, on our number line again, here's 42. We're going to subtract negative 17, which means we're going to do the opposite of move left, which is move right. It's the same as 42 plus 17, and on our number line, that moves us up to 59. So go ahead, pause the video, work on these four problems, give you an example of the ways that subtraction works when we have various versions of the same numbers. Remember, the process for subtraction is adding the opposite. So go ahead, pause the video, work on these, come back when you're ready to move on. Then we have that example, or that advice that we have for it, and then that would be the end of the video. So pause the video, work on this, come back when you're ready to move on. Well, 25 minus 18 in the upper left is 7. We're familiar with that. Negative 25 minus 18 in the bottom left. The opposite of moving left by 18 is moving right by 18 is moving left. So this is the same as negative 25 plus negative 18, because subtracting 18 moves left. That means we're moving left twice in a row, first to negative 25 and then 18 more. In the same direction is negative 43. Those two numbers have the same sign, so we add their absolute values to get our distance from 0. In the upper right-hand corner, 25 minus negative 18, subtracting a negative 18, the opposite of moving left, is the same as moving right. So that is 25 plus 18, adding the opposite. So if we're subtracting a negative, we're adding a positive. That gives us 43. And then finally, negative 25 minus negative 18. That's negative 25 plus 18. Add the opposite. We start at negative 25 and move 18 to the right. We end up at a distance of 7 away from 0, because that's what 25 minus 18 is. Movements in different directions. But we're still on the negative side. So we have negative 7. And now, as promised, that piece of advice, remember subtraction is a matter of adding the opposite. But if you're not entirely sure what's going on in terms of movement on the number line, then really there's one phrase that I like to use to remind us that we can always go to the number line to figure out what's going on. When in doubt, draw it out on the number line.